Problems occurred when scientists tried to examine cosmic rays, as they couldn't be explained using just protons, neutrons, and electrons. So using particle accelerators, they detected many new particles, and after much research, they discovered that protons and neutrons were made up of smaller particles called quarks. Okay, I now want to talk about particle physics. Particle physics is the branch of physics that evolved from nuclear physics, and is concerned with studying the particles that are the constituents of matter and radiation. This is what's called the Standard Model. It shows us all the particles that are the building blocks of everything. These are called elementary or fundamental particles, as they are not known to be made up of any smaller parts. They are therefore the basic building blocks of the universe from which all the particles are made. These particles are split into two classes called bosons and fermions. Bosons are usually force-carrying particles, and fermions are generally associated with matter. The reason for this distinction involves quantum mechanics, whereupon bosons have what is known as integer spin, for example 1, 2, 3. Fermions have half-integer spin, for example a half, 1.5, 2.5. Also, bosons with the same energy can occupy the same place in space, whereas fermions cannot occupy the same place in space, or the same quantum state. This is why bosons are usually force-carrying, and fermions are usually associated with matter. The Pauli exclusion principle is what governs this behavior characteristic of fermions, and simply states that no two identical fermions can occupy the same quantum state simultaneously. The principle gets its name from Wolfgang Pauli, the physicist who formulated it in 1925. Fermions are split into two types of groups of particles called quarks and leptons. The difference between these two is that leptons don't interact via the strong force, whereas quarks do. Bosons are the force-carrying particles and account for the three of the four forces of nature. These are the photon, which carries the electromagnetic force, the gluon, which represents the strong force, and the weak force is represented by the W and Z bosons. The newly discovered Higgs particle is also a boson, and is the particle that represents how matter comes into the universe. The remaining force of gravity is represented by a theoretical particle called a graviton, but as it is yet to be discovered, it is not included in the Standard Model. For some reason unknown to us, nature has made two exact copies of itself regarding fermions. They are in every way identical to the first generation of particles, only heavier. Of the quarks, only the up and down quark are stable, and therefore make up normal matter, which is protons and neutrons. Composite particles of quarks are called hadrons, of which there are two types, which are baryons and mesons. Baryons are composed of 3 quarks and mesons 2. The particles that make up the atomic nucleus, which are protons and neutrons, are baryons and therefore contain 3 quarks. The proton, 2 up and 1 down, and the neutron, 2 down and 1 up.